Construction contracts are too often drafted by legal advisors with little or no handover to the delivery teams. Contractual provisions are then not understood or implemented. This affects cash flow through the supply chain, management variations, and a host of other measures. Our team, City Slickers, came from a diverse background of data and project professionals who met for the first time at Hack 19. The problems we are solving. The UK Construction Act provides a statutory payment process where an agreed construction contract is not in place. Whilst an important measure in preserving cash flow, this still has issues. The key problems we are solving are the manual processes, lack of transparency, and inconsistent audit trail associated with the construction payments. How we solved the problem. We approached the problem in 3 stages. Firstly, we undertook a review of the scheme for construction contracts. This was to create a simplified process flow of the payment timeframes that could be used to communicate with all stakeholders affected by it. This was a manual review given the time constraints of the hackathon. However, using this stage could be automated to parse longer and more complex contracts into simpler process steps. We've undertaken initial development on this using an LDA topic model. Secondly, we developed the process flow to show the inputs, outputs, senders and receivers that will be required for a blockchain ledger. The key steps were the application for payment and payment notice. We used a simple example of an activity schedule for a facade panel, with the subcontractor submitting an application for full payment and the main contractor certifying this at 50% complete. Finally, we used a combination of Rust to develop a blockchain ledger and Node.js to develop a front-end interface. So we have a short video of our prototype demo, which we'll show now. This shows the front end using Node.js with the blocks being created, moving up from 49 to 50 here. On the left-hand side, it shows the people on the blockchain, which will be amended to the contractor or subcontractor names or project name if required. The right-hand side shows the transaction values, which will be the cumulative payments made. And under the transfer, we can show making a transaction to Eve in this example. So it's added in the transfer, it's created, the block is added, and then when we scroll up to the top, we can see the ledger with Eve having that transaction value added against her. So very early prototype, but it does show the direction of travel that the team are moving in. If we then move on to the benefits, so using blockchain creates a more streamlined process with reduced handoffs and manual inputs. The immutable aspect of a blockchain creates a transparent and auditable record of payment applications and what was certified against them. In the event of future disputes, this will reduce the time and cost of legal discovery. The ultimate benefit with a blockchain payment system is that the timescales stipulated for payments will be made. We've also looked at a few add-ons for further development. So the blockchain could be linked to a Power BI model to show progress on site and providing an interface with the blockchain. Using the quality assurance process of a construction project, the workflow of forms, snags, and final sign-offs can be aligned with the production process of a building element, connecting the data from the digital field to the blockchain and vice versa. As building elements are constructed and installed, a QR code is linked to that asset for the QA workforce. Once the building components are installed on site and awaiting final sign-off, this step triggers the activation of the payment application for the building components on the blockchain from the data captured on a digital field tool. In the final stage of the QA process, sign-off is the first time the main contractor and subcontractor agree the work has been completed. This whole point triggers the payment approval on the blockchain, releasing funds to the subcontractor and completing the transaction. If we move on to our questions, so we asked 3 separate questions. Firstly, about future automation and what this could bring to connect site validation to the smart contract. Considered 4 different elements, RFID or QR tags, which we talked about in our example, so connecting the virtual and the physical assets, using 3D photo or point clouds to measure site progress, using drones to complete LiDAR surveys, for example, and cut and fill elements of works, and also geospatial data using flyovers as well. The second question was around configuring the blockchain to enable contracts based on where we are now and our next steps. So good progress in terms of running a blockchain, which was great work from the team, but we're yet to configure it to run smart contracts with the contract logic. So we would do that using the palettes within the programming language of Rust. So they are templates which allow us to configure them to our particular needs and requirements. So we'd use that and see if we can use that for the logic. The final question was around the contractual amendments needed. The most obvious is around payment clauses, so making sure that that aligns to the requirements or the process flow we set out for blockchain. Probably less obvious is around notifications and communications. So if we're going to use blockchain to communicate, we need to make sure that's in there in the contract as an agreed method. And then finally, data confidentiality considerations. So to summarize, we envisage a payment mechanism that is not the subcontractor truth or the main contractor truth, but a data-driven single source of truth that works for all.